signals need to be in the embed? Why can't you just do the normal similarity search and then apply those as like pre-filters or post filters? Like we've got great mechanisms for doing that kind of stuff. Why bother putting it in the vector?
Very good question. Almost feels like well, so when you think about ways of dealing with metadata, right? So this is what we have been sort of doing, and it sort of works, right? Is you can filter your data using kind of SQL-like statements or whatever the underlying database offers. You can kind of constrain the search through the vectors with those other kind of more crude operations, right? You can say, when the user looks for a recent news about some topic, you can interpret the word recent as filter, right? You can basically say, okay, show me all the news within the last 7 days, and then that will sort of filter the path through the index, and then all the results that fulfill that sort of predicate get ordered by the similarity of the news topic. The problem of this is basically there are kind of like two problems there, right? One is any kind of filter representation for kind of a goal that's actually not a step function, right? Will be arbitrary. Is it 7 days? Is it 8 days? You don't know, right? We can argue about like, can you bind research on the filter, right? But it gets complicated. So that's kind of part of the problem. And then even if somehow magically for a given topic, you figure out, okay, it is some kind of filter that maybe makes sense. Then still everything that passes you need to order by the vector, and you're sort of combining within your infrastructure this nearest neighbor search in vectors with the filtering, and that gets complicated for big indices, right? Because they're sort of combining two different index structures. And if you're a very big company, you can maybe build these systems completely from scratch and do all kinds of scoring in your shards and merging and complicated. But then that's where we actually work with that. And so by expressing all the signals of both the data and the expectations of the goals of the query in the vectors on the both sides, then you can just do cosine similarity, right, to navigate those trade-offs. Then it's this kind of way to standardize.
So, okay, I want to repeat it back to you in a different frame and see if you align with it. So, is what you're kind of pushing on here sort of like the bitter lesson, but applied to the embedding space too? So instead of saying like, well, like we're going to train this really bespoke thing for like the core of the model, and then we're going to have all these other like extraneous pieces, and we're going to try to make those work in harmony. You're sort of bitter lessoning us and saying, no, put it all in the stupid model and let it handle everything.
So that now talks to the model problem, right? So basically, yeah, like when we somehow make the leap and say, okay, let's express all our metadata into the vector, how do we do it, right? And that's a model like, so how do we train a model that can eat all these different signals? Some of it might be text, some it might be numbers, and so on. And it can produce a vector that somehow encodes all of this stuff, right? So that's a modeling problem. And yeah, you can kind of feature engineer all those signals and train an encoder that produces a vector that if you then use it for the downstream task, it performs well. Or if not, you propagate the error into the encoder and you kind of do all this work and eventually get somewhere, hopefully. And this is how it's, by the way, done in kind of the big companies, right? Custom encoders, nobody's stringifying, big JSON files and adding them through a language encoder. It's custom. But then it's a big project, and often those vectors are kind of single purpose for that one given task. So, ideally you find some way to productize this, right? And our approach is, actually your data, even if it's a complex entity, is made out of a bunch of different properties of different types, right? Numbers and, timestamps and text and so on. And we are all very, we have the benefactors of people doing all kinds of encoders in the open source world, and they can encode these different kinds of data by themselves, right? And then for some of these properties, like the timestamp, you don't actually need a model to encode the timestamp in that way, and then it's like, there is some like caveats there, right? But that's sort of the approach that seems to make sense. That basically you somehow solve the encoding problem for each of your properties of the entity, for each signal independently, and then find a way to stitch those partial encodings into a customer vector or product in the e-commerce setting, the product vector or patient record vector, right? That somehow aggregates all these different signals and does it accurately. And is then kind of the basis for asking questions against the data set in a way that now the vector actually contains the different signals for you to be able to pull that out, and you don't have to kind of do filters. You don't have to go re-ranking as much. And, the problem of, we're probably drawing there. The problem of re-ranking is it only applies to a tiny fraction of your index, right? So if you have to resort to re-ranking, you are applying the scoring function to a tiny fraction of your index, and you don't actually want to do it, right? The only reason you would do it is that the function is too slow to run over your entire data set, right?
Yeah.
And so that there is this tension there that, like, if you can't express the scoring function by a vector that then does the similarity search, that's just better because it's evaluated versus the whole system.
Understood.
And then, you can do things for re-ranking to kind of refine the edges.
Yeah.
But re-ranking alone is not going to solve the big